So this is Vincent. That's Momo.
Hello.
Oh shoot. This is AP Physics lab for calculating terminal speed, and we're finding the relationship between the unit of coffee filter and the terminal velocity. So there are two probabilities, whether it's proportional to the velocity or it's proportional to the square root of velocity. So now Momo will introduce the procedure.
So first, Vincent gonna drop just one coffee filter down, like under the motion detector, so we can graph the velocity graph on the computer, and then we can find the terminal speed for each one. Then we do two coffee filters, and then three coffee filters, and so on.
After getting those data, we will plug in those data into Microsoft Excel and then graph it to see whether it's proportional, whether it's linear, or if it can be a parabola, it can be a square root graph, so that we can determine the relationship between the mass and its terminal velocity in order to find the blah blah. Shall we start?
Yeah.
So continue. You may not be able to see, but
No, they cannot.
yeah, but I don't think it matters. So on the graph, from the motion detector, the motion detector is able to tell us the graph of the velocity. So we will find the part of the velocity that the slope is almost zero, which tells the terminal speed. And then we record the data. For this one, is the first trail is 0.5841, and then we do another trail, the second trail, the third trail, and then we average them so that we can lower the amount of error contained in the lab. So let's do it for the second half.
Right, do we need to? Oh.
This time the data shows the terminal velocity 0.533 meter per second. We can do another one. The third time is 0.5635. So by calculating those three data, we get the average terminal velocity 0.5602, which is the average terminal velocity for 1 unit coffee filter. And Momo will demonstrate for the second for two coffee filter. That's good.
Okay.
The data set.
So the first one we get 0.646.
0 meter per second.
Yeah, meter per second.
That's for terminal velocity.
Yeah, and just do it again. So the second data we get is 0.7142 meter per second. The third one for two filters is 0.9152, and we get average of three of them is 0.759. So that's
Awesome.
it. Yeah.
Now we have 3 coffee filters. We did the same experiment, and I will just skip this redundant parts. We calculate the average terminal velocity for the terminal speed of 3 coffee filters, and the average is 0.9688 meter per second. Same process, and we have already got our data on my lab notebook, so skip those process. And for trio 4, we did 4 coffee filters. Another one. We did the same thing, 3 times 3 trails. We calculate the average terminal velocity of 4 coffee filters, which is 1.108 meter per second. Now we have 4 points. The first point is 0.5602. That's the first point for 1 coffee filter. And then 2, 0.759. 3, 0.9688. And 4, 1.108. After getting these 3 points, we plug after we getting those 4 points, we plug those 4 points into the Excel graph, which you can't see because this is my computer. But the graph showed a very obviously trend that the function is supposed to be a square root function. We also tried cube root, but obviously the square root fits better. So this is our lab. Thank you for your attention and
Thank you.
have a good day.